So index numbers are just numbers that summarize large systems. So things that are complicated, basically, right? And that involve a bunch of numbers. They help us use one number to kind of summarize what's going on. All right, and so the one that we're going to talk about today, it's going to provide a simple way to compare measurements made at different times or in different places. The value at one particular time must be chosen as the reference value. So to find an index number, you just take the value that you're interested in, you divide it by the reference value, and you multiply by 100. And there's a little note at the bottom there. It just says there's no particular rule for rounding index numbers, but we'll round them to the nearest tenth. Okay? All right. All right, so here's an example. Table 3.2, we look at average gasoline prices per gallon. And so we're given them at decade years starting at 1960 through 2010, right? So in 1960, the price was 31 cents a gallon. In 70, it was 36 cents, and so on and so forth. 2010, it was $2.84. Well, if we use the 1980 price as our reference value, then we can calculate the price index of gasoline based on that reference value. And all we have to do, right, is, for example, let's take the 1970 price, which was 36. And if I want to calculate an index with 1980 as a price index with 1980 as the reference value, I would take that 36 cents and I would divide it by the 1980 price, which is $1.22, multiply by 100. If you pop that in your calculator, you should get 29.5%. And then when we write numbers as indices, we don't write a percentage sign, even though they technically are percentages, okay? And so likewise, you can see everything before 1980 is less than 100. 1980 is 100 because that's the reference value we're using for the price index, and then everything after 1980, since it just gets more expensive, has an index above 100. All right, I'm getting some. Suppose the cost of gasoline today is $3.77 per gallon. Using the 1980 price as the reference value, find the price index for gasoline today. So we're just going to take the $3.77. We're going to divide it by our reference value, which is our price in 1980, which was $1.22. I get 3.09. Multiply that by 100. That's 309.0. There's my price index. Is that what gas actually costs today? Aaron, what does gas cost right now? Oh, it's $2.29, my wife says. She's like an encyclopedia for gas. She comes home and tells me what gas prices are for some reason. So the actual price index is cheaper than that. Gas prices have been going down though because, well, right now nobody's driving, but also probably the popularization of the electric car. All right, so that's 1.877. So 187.7 is actually today's price index for gas. It just tells you, so this just gives you reference to another point in time, right? So the index number just tells you, since I'm using 1980 as reference, it's what percent of the 1980 price are we paying right now, basically. We're paying 187% of the 1980 price. All right. Suppose it costs $15 to fill your gas tank in 1980. How much did it cost you to buy the same amount of gas in 2010? So this, hopefully, Naomi, this will give you some more context to that. So all we're going to do is this is a lot like unit conversions. So this is kind of how I want you to think about using these indices. We're just converting from, like, in this case, we're converting from $1980 to $2010. So let me go back because there's a couple questions. Are you talking about this table, Kai? What do you mean, what are the other numbers for? Yeah, so notice that these are the exact same, right? We've just dropped the percentage sign. So that's just something that when we talk about indices, we don't talk about them with percentage signs. That's just a notation thing. So all they are, it's to show you kind of, it's just step by step, how are we getting here? We start with the price, we divide it by whatever our reference price is, we multiply it by 100. It's technically a percent, but we drop the percentage sign when we talk about it as a price index. All right. So let's move on to this next example. The price index, okay, so I'm sorry. It cost $15 to fill your gas tank in 1980. How much did it cost to buy the same amount of gas in 2010? So we can just look at, since 1980 is already our reference value, these price indices are all with reference to 1980. So if I look at the 2010 price index, we have 232.8, right? Basically, gas costs 232.8% of the 1980 price. So what I can do is just use that index. So it's going to cost you 232.8% of that $15. All right, so to actually convert this to an equation, we need to rewrite 232.8% as a decimal instead of a percentage. So 232.8 as a decimal is 2.328. And now I can change the of to just multiplication. And multiply that out. We end up with, it's going to cost you $34.92 in 2010. All right, so remember, to calculate an index, you need a reference number. And the reference value is basically allowing you to compare to that number. So here's the same table, this column is the price index, where 1980 is our reference value. And then this one is the price index if we instead use 2000 as our reference value. So let's just look at a particular year. Let's look at 1970. If I use 1980 as my reference value, then to compute the index, I would do 0.36 divided by 1.22 times 100. And we end up with that 29.5 as our index number. If we use 2000, we take the same 0.36, but we would instead divide by the price in the year 2000, which was $1.56. And that's going to leave us with 23.1. Oh, whoops, sorry. 0.231, I should say. But I multiply by 100, so 23.1. All right. So let's do another example using 2000 as our reference value. Find the price index of today's gasoline. If the price is $3.77 per gallon. Well, we would take that 377, and this time we're going to divide by the price of gas in the year 2000, so $1.56, since that's our reference value. And we'll multiply that by 100. And that gets me 241.7 as my price index. So basically that's just saying we're paying, 241.7% of the price we paid in the year 2000 for gas. How does that compare? To 1980, oh no, I'm sorry, I'm looking at the wrong example. Our 1980 price index was 309, so we were paying 309% of what we paid in 1980, but only 241% of what we're paying in the year 2000. So all right, it's smaller than the 1980 price index since gas was more expensive in 2000. All right, so now let's talk about some common indices. So there's this thing called the Consumer Price Index, the CPI, and it's based on the average prices for a sample of more than 60,000 goods, services, and housing costs. And it's computed by the federal government and reported monthly. And we actually use that to determine inflation, because as that number fluctuates, we can compare how much those same 60,000 goods, services, and housing costs cost from one month to the next, and that will give us some idea about the value of money from one month to the next. So the rate of inflation from one year to the next is usually defined as the relative change in the Consumer Price Index. All right, I'll give you a moment. These are important definitions, so make sure you get them down. So here's a table of consumer price indices for the years 1976 through 2012. And I think this book was published in like 2013, which is why it only goes to there. And it's using an average of the years from 1982 to 1984 as the reference value. All right, so these tables, note that you're going to need them to do some of the problems in your homework. They're in our slides in the module, so you can just open the slides in under week 19 module to access these tables. There's just a PDF of the slides. All right. Suppose you need $30,000 to maintain a particular standard of living in the year 2000. How much would you have needed in 2012 to maintain the same living standard? Assume that the average price of your typical purchases has risen at the same rate as the consumer price index. Okay. So I kind of do these a weird way because I like to treat this like unit analysis because I think it's more familiar to something we've been doing in the previous unit. So here's what we're gonna do. The $30,000 that we're talking about is in year $2,000. So I'm just gonna make a little subscript note of that. And that's going to kind of act as my units. I know my technical units are dollars, but these are year $2,000, right? And what we want to do is convert those to year 2012 dollars, okay? And so the way we're going to do that is using our CPIs, our consumer price indices from those years. So basically, before I actually look them up, we're going to take the CPI for the year 2010, or 2012, sorry. And we're going to divide it by the CPI for the year 2010. And consumer price indices don't have any actual units. So when I multiply this by the 30,000, my real units will still be dollars. But I want you to think of these years as another kind of unit. So I'll put this over 1. And what you can see is going to happen. Oh, I'm sorry, 2000 was supposed to be the year for my denominator CPI, 2000. And what we'll see is just like in unit analysis, the units will cancel in a way that we want them to. So my $2,000 will cancel, and it will leave me with units of $2012, which is what I want, right? All right, so let's actually go up and look up these CPIs. So the CPI in the year 2012 was 229.6, and in the year 2000, it was 172.2. So 229.6. All right, so 229.6 over, what was it? 172.2. And again, this is my CPI for 2012. This is my CPI for 2000. I'm going to multiply that by $30,000. And those dollars are actually year $2,000. And so again, my years cancel in the way that I want them to, and it's going to leave me in 2012 dollars. Let me just make sure that 2000 CPI was right. Yeah, 172.2. Okay. No, there won't be, Trey, but you will need, so there won't be anything that you need to know. But you will need this table. You'll need to access this table. But again, that's just in the slides, which are a PDF under our current module. All right. So in the calculator, I'll just do 229.6 divided by 172.2 times 30,000. That's actually $40,000. So you would actually need $40,000 to maintain the same standard of living in 2012 that you had in the year 2000. And so when I say standard of living, to have the same size house, buy the same groceries, drive the same, type of car. Let's update it though. 2012 was 3 million years ago. Let's say we wanted to update that to 2021. I bet we can look that up. Hey Siri. Well, of course it doesn't respond. But if I say like, hey Savannah, my Siri will go off. If I'm like calling on a student whose name starts with an S. Hold on, we'll look it up. But what we want to do is, right, same deal. I would do CPI, but then I want to end up in dollars of year 2021 divided by CPI of the year 2000. And then we're going to multiply by that $30,000, which is in year 2000 dollars. All right, but we need the most current CPI to do that. Let's see. Okay, it rose 2.3%. Oh, here we go. 260.82. All right, so oh, whoops. So now to maintain that same standard of living, you would need $45,439 approximately. Inflation rate from 2011 to 2012, how does it compare to the inflation rate in the late 1970s? So remember that inflation rate, we define that as relative change in CPI. And so the way you would compute relative change, remember, specifically in CPI, is you would take your CPI new, subtract your CPI old, and then you're going to divide that by your CPI old. Okay? So for 2011 to 2012, we're going to take CPI 2012, subtract CPI 2011, divide by CPI 2011. All right, let's go back and look at what those were. So there we go. So 2012 is 229.6, 2011 is 224.9. So I'll just do 229.6 minus 224.9 divided by 224.9. Remember, in your calculator, that numerator, you can do that all at once, but you need to put that numerator in a set of parentheses. And we get approximately 0.021, which as a percent, it's about a 2.1% inflation rate. One thing I want to mention, so inflation is just the value of the dollar, and as inflation increases, the value of the dollar decreases. So inflation isn't good for your money. It's making it worth less, right? Okay. How does that compare relative to the inflation rate in the late 1970s? So let's just go ahead and assume by late 1970s they mean 78 and 79. So we'll do the same thing. All right, so we just need to look up those two values. So 78 and 79 are, oh, no, 77, 78, are 65.2 and 72.6 respectively. So we'll do 72.6 minus 65.2, and we'll divide that by 65.2. That comes out to approximately 0.113, which is 11.3%. So the inflation rate in the early 2010s was much less than that of the late 1970s. Which just means that the value of the dollar was kind of plummeting in the late 1970s. And you can also kind of see that in right here in the chat, what happened here. You were alive for this, but you were pretty young. Does anybody remember what happened there? Notice how the CPI changes pretty drastically, similar to the way that it did in 78 and 79. Yeah, there you go. The housing market crash happened, which caused a lot of people to lose their homes, which affected the economy negatively. And usually when there's some sort of a negative impact on the economy, that'll cause inflation and changes, dramatic changes in the consumer price index. All right, I already kind of talked about this, but this is how you adjust prices for inflation. So given a price in dollars for the year X, the equivalent price in dollars for the year Y is found using this kind of formula. And this is just the one I liked to use. I even did that for, that example where we saw what $30,000 in the year 2000 would be in the year 2012 and in the year 2021. And so you just treat these years almost like units so that you can do some unit analysis and end in dollars in the year that you want them to be in, okay? All right, I think we got one more example, so I don't want to rush you through this. All right, last example. In 1987, the average salary for Major League Baseball players was $412,000. In 2012, it was $3,440,000. Compare the two salaries in 2012 dollars. How does the rise in baseball salaries compare to the overall rise in prices with inflation? All right, well, first let's put them both in year $2,000. So the 3,440,000 is already the current the 2012 average salary. So I'll just make a little note there. All right. So let's take the $412,000 and that's in 1987 dollars. So I'll make a little note there, 1987. And what I want to do is convert that to 2012 dollars. So I'm going to multiply that by my CPI in 2012 because that's the year I want my dollars to end up being in. I'm going to divide by my CPI in 1987 dollars, and that way those years will cancel and I'll just end up with dollars with 2012 dollars. All right, well, first I need to look up those CPIs. So all right, 2012 was 229.6, 87 was 113.6. 229.6, 113.6. So 229.6 over 113.6 times $412,000. So that's about $832,704.23. All right. So if baseball players were being paid the same relative salary just in 2012 dollars, they'd only be making on average $832,704.23. But what they're actually being paid on average is $3,440,000. So what that's saying is that the rise in baseball salaries far outpaces inflation. Right? So just to make sure you guys understand, this number is just saying that if the average salary stayed the exact same and the only thing that changed, over those 30 years or whatever was inflation, then baseball players should be on average making $832,000. But what they're actually making on average is $3,440,000. So baseball salaries increased not just because of inflation, but because of other things. Maybe the rise in popularity of baseball players or the demand for baseball, but they're making way more than they would be if it were just for increasing inflation. I think that's it. Yeah. So your homework is just